Hello everybody. Today I want to start showing you how to balance a chemical equation. This is a balanced chemical equation. The first thing we have to know in order to really start talking about balancing equations is we got to get some vocab down. Everything before this arrow is called a reactant. So these are the reactants of this chemical reaction, of this equation. Everything after are called products. This arrow right here is called the yields sign. I many times will say makes. So hydrogen and oxygen make water. Now you already know that those numbers after the letters, and I'm even going to underline right there because we know there's a 1 there, we just don't write it. Those numbers are called subscripts. But now we have a new thing that we need to look at, and that is the fact that there's a number in front. Now I'll underline there again because we know there's a 1 there, but we don't write number 1s as this number either. These numbers, just like in math, are called coefficients. So, as you look at this equation at the top, look at the model set I have set up on the bottom. What this is saying is hydrogen, which is H2, and oxygen, O2, make water. But we have to balance this equation. Because of the law of conservation of mass, if we did not have coefficients out there, and all of these numbers were simply 1, 1, and 1, you should notice that an oxygen looks like it disappears. That on this side we have 2 hydrogens, 2 oxygens, but on this side we have 2 hydrogens but only 1 oxygen. That makes it look like an oxygen just flat out disappeared, was destroyed. The law of conservation of mass says matter cannot be created or destroyed. All it can do is break bonds and then come together in a different way. So, by putting a 2 in front of H2O, by putting a 2 out here in front of H2O, we now get 2 H2Os, and then we put 2 out there in front of H2, and now if you see, you will notice that there are 4 white hydrogens on each side and 2 red oxygens on each side. That makes this a balanced chemical equation. So, let's start talking about counting these things. So, if I were to say that's what we had, all I would do is write H2O. But if I have 2 of them, then I put a 2 out in front. If I have 3 of them, I put a 3 out in front. And if I have 4 of them, and so on and so forth, in this case, I'd say 4. But if I want to count these, in order to count this has no parentheses in it. That makes it really easy. There's a 1 behind the O you can't forget about, but if I want to know how many hydrogens this has, 4 times 2 is 8. And then count how many hydrogens there are. 1, 2, 3, 4, 5, 6, 7, 8. If we then want to know how many oxygens there are, 4 times 1, we get 4, and then count them. 1, 2, 3, 4. That's how we figure out how many atoms are in something like that. Well, let's take that one step further, because we know that there are going to be examples where we have parentheses in it. So if I have 9 Ca3 PO4 to the 2, this was a problem on our ionic compounds quiz, and I make a list of all the atoms. Calcium, there's phosphorus, and here's oxygen. If I don't have parentheses, you have two numbers to multiply. 9 times 3, 27. If you do have parentheses around your element, then you have three numbers to multiply. Don't forget there's a 1 behind that P. So 9 times 1 times the number outside the parentheses, 2. 9 times 1 times 2 is 18. Oxygen has a number behind it, so 9 times 4 times 2, if you do the math, 9 times 4 is 36, 36 times 2 is 72. That's how you count atoms in things. So, the very first homework you will receive is worksheet number 1. And worksheet number 1 has a problem. Let's do number 1 together. All you have to do is count how many atoms you have on the reactant and product side, and then tell me if it's balanced or not. So let's quickly count everything. Calcium is right there. So calcium is not in parentheses. 3 times 1, 3. Now oxygen, you have to be careful. Oxygen is there, and oxygen is there. So 3 times 1 times 2 is 6, and then 2 times 4 is 8. There are 14 oxygens in this. 14. Hydrogen is also in everything on the left. That hydrogen's in parentheses. 3 times 1 times 2 is 6. This one is not. 2 times 3 is 6. We get 12. Now, phosphorus. 2 times 1 is 2. Now let's count all those things over here. Calcium, 1 times 3. Now let's do oxygen. It's in both things. That one's in parentheses, that one's not. 1 times 4 times 2 is 8. 6 times 1 is 6. 8 plus 6 is 14. Hydrogen is only here. 6 times 2 is 12. And phosphorus is now in parentheses. It wasn't over here. 1 times 1 times 2 is 2. And when you see these two lists, they are the same. That is a balanced chemical reaction. Do that for the other 9 problems, and that will be the first thing we go over. Now let's go back and let's try to recreate what we had for that first problem I showed you. On paper, equations will always look like this. All we are ever intending to do is put coefficients out in front. Currently, as written, without coefficients out in front, we are saying that we have one of each of these, which is why I have 1 H2, 1 O2, and 1 water. But as I stated before, as currently written, this cannot happen because there is one oxygen that just seems to be disappearing, and that cannot happen. So to do it on paper, make a list of what you have. We have hydrogens, we have oxygens on that side. You will always have the same list on the product side. So now on paper, let's count what we have. 1 times 2 for hydrogen, 2. 1 times 2 for oxygen, 2. On this side, 1 times 2 for hydrogen, 2. 1 times 1 for oxygen, 1. And that's what our picture shows. Well, now, by putting coefficients out in front, we are going to balance this thing. So, we balance it. Hydrogen already is. So now, I want to turn this 1 into a 2. I cannot just put a 2 there and say, oh, I'll just make it H2O2, and now that becomes a 2. We can't do that. This is not water anymore. This is hydrogen peroxide. you have completely changed the Lewis dot structure, the chemical, physical properties. You cannot do that. All we can do is put a number out here in front. That's currently a 1. So what times 1 would give us the 2 that we want? 2 will. So we now have 2 waters. But not only did that change the number of oxygens, because if we put a 2 times 1 to get 2 for oxygen, we now have 2 times 2 for hydrogen. So yes, hydrogen was okay, but when we fixed oxygen, we messed hydrogen up. But now we have 2 red oxygens on each side of this equation. Well, what can we do to now make this 2 a 4? Currently 1 times 2 is 2, but I don't want that to be a 2, I want it to be a 4. We already know from seeing this earlier that a 2 out in front, 2 times 2 is now 4. We put another hydrogen out here, and you now have a balanced chemical reaction. I chose one like this to start off simply. Obviously, this gets a lot more complicated. So, let's do one off of one of the worksheets. Here is worksheet number 2. I make the list for you, allow you to work, or give you room to work on the problem. Worksheet number 3 has a lot more problems, but I also don't give you nearly as much room to work. And then worksheet number 4 has 40 problems, and I don't give you any room to work. Oh, and look what the first problem is on that worksheet. So let's look at worksheet number 2, and let's at least work a problem or two. Let's do this problem. Okay, H2O2 makes H2O and O2. Currently all those coefficients are 1. So 1 times 2, 2. 1 times 2, 2. Hydrogen and oxygen on the other side. 1 times 2, 2. Be careful counting oxygen. It's in both things. 1 times 1, 1. 1 times 2, 2. 1 plus 2, 3. Hydrogen is balanced. Oxygen is not. But how can I make a 2 become a 3? This is a little bit more complicated. This number is always going to be even. I don't care what number I put here. It's always going to be some kind of even number. But I could change this number. What I'm going to do here is I'm going to put a 2 there and see what happens. Because I need, these are always going to be 2, 2, 4, 4, 6, 6. Because those are both 2's. That's always going to be even. So let's just try to mess with this number and change it from a 1 to a 2. I want to do that to fix the oxygen. Well, there's 2 oxygens there. 2 times 1, we now have 4 oxygens. But by putting a 2 there, I've messed with the hydrogen as well. 2 times 2 is now 4. Well, that's great, because now I have 2 4's over here, 2 2's over here. I put a 2 right there. 2 times 2 is now 4. 2 times 2 is now 4. 2, 2, 1. I don't even write it. I don't say it typically. 2, 2, 1 is a balanced chemical equation. Let's look at the next one very quickly. Sodium, 1 times 1, 1. Oxygen, 1 times 2, 2. On this side, 1 times 2, 2. 1 times 1, 1. Well, if I do anything over here, it's not going to fix the problem. Any numbers I put there are not going to switch these. Let's just make this number twice as big. I can make this oxygen a 2. Let's change color just to show this. I can easily put a 2 here because 2 times 1 will change this oxygen to 2. But when I did so, 2 times 2 is 4. Okay, oxygen's balanced now, but sodium is not. but what number can I put out here in front of sodium to make it 4? I can put a 4 here. 4 times 1 is now 4. 4, 1, 2 balances that chemical equation. Continue to do worksheet 2. Continue to do worksheet number 3 if you can. Look at 4 if possible. Count them on worksheet number 1. I'm going to make all these worksheets available so you can work ahead and do as many of these problems as possible. As a final thing I want to show you, I did a project. I went for a big grant a few years ago, and when I did, I wanted to show that these models are great things to use, and when I did, here is a model set that I used to show a balanced chemical equation. This is 2C2H6 plus 7O2 yields 4 CO2s, carbon dioxide, plus 6 H2Os. Look at this entire equation as an equation and as models. 2 C2H6s plus 7 O2s make 4 CO2s and 6 H2Os. But now count. There are 4 black carbons on each side. There are 12 white hydrogens on each side, and there are 14 red oxygens on each side. If we had 1s out in front of all those, this would not even be close to balanced. But once we put and balance this equation, you can see why everything works out. Please watch this video as many times as necessary. This is one of the most difficult things you've ever done in your academic life. Please take your time, ask questions, work with friends, and good luck.